This tutorial is all about covalent bonding, and we learnt about covalent bonding briefly in module C1 because we learnt about the alkanes and the alkenes, and we learnt that alkanes consisted of atoms of carbon and hydrogen joined together by covalent bonds. We learned that covalent bonds were a shared pair of electrons. So having learnt about ionic bonding in this module, we now learn about a second kind, covalent bonding, which occurs only between non-metals. Non-metals combine together by sharing electron pairs. This is covalent bonding. Metals react with non-metals by ionic bonding, in other words by transferring electrons from atom to atom, whereas non-metal elements react with each other by sharing electrons in covalent bonds. Carbon, for example, is a non-metal, would need to lose or gain 4 electrons to form an ion, and instead it shares electrons when it reacts with hydrogen, for example, to form methane. The carbon atom has 4 electrons and wants a full shell of 8. The hydrogen atom has got 1 electron and needs a full shell of 2. By overlapping their shells, as shown here on the right, carbon has the appearance of having 8 electrons in its outer shell, and the hydrogen has the appearance of having 2 electrons in its outer shell. Instead, the electrons are shared between the two in these 4 bonding pairs. So the formula of methane is CH4 because it contains 1 carbon and 4 hydrogen atoms, and we can draw each of these covalent bonds as a stick in a diagram like this, displayed formula shown here. So a covalent bond is a pair of shared electrons. Whereas ionic compounds form giant structures of many millions of ions electrostatically attracted together, many covalently bonded compounds form molecules with different kinds of properties. Here's a diagram of what water molecules look like. Now each of these water molecules would consist of an oxygen atom covalently bonded to 2 hydrogen atoms. And here would be another one, an oxygen joined to 2 hydrogen atoms. Now there are very strong covalent bonds within the molecules, and these don't break whether we melt the ice or boil the water that's made. These strong covalent bonds remain intact. However, in ice there are very weak attractions between one molecule and its neighbours. These weak attractions are easily overcome, and therefore these substances have got low melting points and low boiling points. So, covalent molecules like carbon dioxide and water have got low melting points. Another property where they differ from ionic compounds is that they don't conduct electricity when they're molten, or when they're evaporated, or when they're solid. They simply do not conduct electricity because they don't have any charged particles and they don't have any free electrons that can carry any charge.